Welcome to Civilsoft Structural Consultants and Trainers Bangalore. So today we'll be discussing about the design package what we have at Civilsoft. This is for civil engineering students and structural engineering students. So let's get started and let's discuss what all will be taught at Civilsoft under this particular package. So to start with, to construct any house, the first thing what we'll be needing is a floor plan. So a floor plan is like what it is shown on the screen. A floor plan gives you the dimension of the living spaces. Now living spaces are like this kitchen, master bedroom, hall, bathroom and all that. So this is the living spaces plan, or we call it as floor plan. So these floor plans are prepared by an architect, be done by a civil engineer. Okay, so once we have prepared the floor plan, the next step is to prepare a GA, general arrangement. See, in this floor plan, the architect is not going to show you what is the size of beam required or what is the size of the column required or what will be the thickness of the slab. So all these details will be given in another set of drawing which is known as the GA. We call it as general arrangement. A GA is prepared by a structural engineer or a civil engineer, and this is how it looks. So in the GA, we'll be mentioning what is the thickness of the slab, what is the size of the beam, what is the orientation of the column. All these details are given in the GA. So to begin with, the architect had prepared and given us a floor plan. So in return, as a civil engineer or a structure engineer, you would prepare a GA and give it to him for approval. We need to get the approval from the architect to start. So the architect will see whether the columns what you have put is affecting the floor plan in any way or not. For example, if you end up putting a column somewhere near the entrance, then it becomes a problem. So the architect is going to check all this and then he is going to approve it. So once you have got an approval for the GA from the architect, our job is to make a 3D model. So this is a 3D model what is shown on the screen. A 3D model can be done in either ETABS or it can be done in STAD. These are two softwares in which most of the design projects are done. So I have shown you a 3D model in ETABS now. So we'll make the model, we'll put the columns, beams and slabs in their particular location using ETABS. And then the next job is to start with the loading. Now what are the different type of loads that will come on the building? Let's see what we have. So in general, these are the basic type of loads what will come on the building. So we have self-weight, floor finish, and wall load. This self-weight, wall load, and floor finish will come under dead load case, and then typical and a typical live and roof live load will come under live load, and then you have earthquake loads. There are more type of loads such as your wind load and temperature loads. So let's discuss that. So these are the various loads what we have in a building. So we have dead load, live load, wind load, seismic load, and temperature load. Now dead load will be further broken down into self-weight, floor finish, and wall load. So we have self-weight, we have floor finish, and wall load. Live load can be split into typical live and roof live. Coming to wind load can be broken down into wind load in X direction, wind load in Y direction, and wind load in, sorry. Okay. So wind load can be broken down into wind load in X direction and Y direction. And then the earthquake load can be broken down into earthquake load in X direction, Y direction, and Z direction. These two are lateral components, and this is a vertical component. This component will be rarely used. And then coming to the temperature load is applied as an axial load to the beams. Now from where do we get this dead load, live load and all? So this all is from this code book IS 875 part 1. Live load will be from IS 875 part 2. And wind load is from part 3. And your seismic load is from IS 1893 2016 and temperature load from this particular code IS 875 part 5. So these are the various loads what we'll be applying on the building. So on the current building, we are going to apply all the loads. So under definition, you can see what all loads we have applied. We have applied self-weight, wall load, floor finish, typical live, roof live, and then we have applied the earthquake loads. Now the values, for example, dead weight, you are going to apply some dead weight on the building. So from where do I get that value? For example, density of RCC you have taken as 25 comfortably. But from where do I get that 25 kilonewton per meter cube? That is from our code IS 875 part 1. Dead load is from this particular code. So let's see that particular code. So let's go to IS 875 part 1. This is IS 875 part 1. Code of practice for design loads other than earthquake for building and structures. Part 1. Part 1 is for dead loads. Now let's see where do we have those values. So if I go to page number 7, so here if I scroll, I'll find the cement concrete reinforced. You'll get the density of the materials. Usually we take around 25, the code says around 24.2. So we assume it as 25 to be on the safer side. So this is from where we get the dead weights. It is from which code book? IS 875 part 1 will give us all the dead loads. Same way if you want for some other materials like brick, stone, this, that and all, you'll get it from here. You can see for all different type of materials, the weight is given in terms of kilonewton and kgs. So whatever type of material you're going to use in the building, the dead weight of that particular material is available in this particular code. So you're going to apply all the dead weight of the walls, floor finish, and those beams and columns. Once you have done that, next your job is to apply live load. Now live load will depend upon the type of building you are constructing. For example, your residence will have a live load of around 2 kilonewton per meter cube. If it's a commercial building, it will have 3. If it's a school building, it again depends 3 or 4. So these values are again available in our code. So as we discussed, live load is from codebook IS 875 part 2. So that values, let's see. Let's go to our code and search for them. I'm opening IS 875 part 2 now. Imposed loads part 2. That is nothing but live loads. Now if you scroll down, you will get a table here. Here imposed loads for different occupancy, that is different type of buildings. If it's a residential building, it is around 2 kilonewton. For balconies, it is 3. Same way, if it's an educational building, schools, colleges, that and all, for classroom, it is taken as 3. And for the corridors, it is taken as 4. So this way, for different type of buildings, the load is specified. So we see this code and we are going to apply that load here. Let's see what load is applied here. So you can see we have applied a live load of 2 kilonewton and 3 for the balconies. So once we have applied the live load, next our job is to go to the next type of case. So the next type of case what we have here is wind load. Now the question is, if you are applying seismic load, you can avoid wind load for RCC structures, because for RCC structures, seismic load is more critical compared to wind load. But if the building is big, then you will have to consider both and see which one is more critical. So in this particular case, we have omitted wind load. Anyway, we will see the code. So for wind load, we will be referring to IS 875 part 2. So part 3, IS 875 part 3 will give us wind loads. So IS 875 part 3 is going to give us wind loads. So wind speed varies upon the type of city. I mean, different cities have different wind speeds. So if you go to page number 53, here for different cities, different wind speed is given. So based on this, we are going to calculate the wind load. How to calculate wind load and the application is explained in the code. So this all we'll be taking it up later. Next, once we have applied the wind load, next is to apply seismic load. Now, seismic load will be broken down into a seismic load in x direction and y direction, and the z is a vertical component. Now, let's see that in the model. So, in the model, we'll go to define load patterns. We have selected EQX, define. So, you can see we have applied the earthquake load in x direction. Same way we have applied in y direction. So, once we have applied all the loads, once we have applied the earthquake load, next is temperature load. So once we have applied the temperature load also in the building, next our job is to prepare combinations. We need to combine all of this. We need to combine all the loads. To combine all the loads, we have code 456 will give us the combinations. So we'll go to 456. We'll go to page number 68. Here the combinations are given. As we are following limit state method, there are two types of combinations. One is limit state of collapse and the other one is limit state of serviceability. So we are going to add this combinations. Combinations are also available in our code book 1893. So different type of combinations are available here. So we'll make the combinations as per our code. Let's see that in our model. So we have added all the different type of combinations. Once you have added all the type of combinations, you are supposed to run the analysis. Now analysis are of two types. One is a static method and the other one is dynamic method. Let's see what it is. Let's see what our code has to say about the type of analysis we are supposed to run. As I was saying, the analysis can be done in two types. There are two types of analysis. This is what the code says. One is equivalent static method, other one is dynamic method. So to run analysis, we have two options. One is to do it as equivalent static method, other one is dynamic method. Dynamic method is further subdivided into response spectrum method, model time history method, and time history method. Now let's see when to use this. Before we get into this, we'll have to discuss about the different zones India has. See, our country, India, is divided into 4 zones depending upon how prone it is to earthquakes. Now you can see this zone 2 is for blue color and then yellow it is zone 3, green for zone 4 and red for zone 5. So you have to see where the building is located and in this area wherever it is located and you have to check which zone it is going to come up. So depending upon the type of zone we are going to run the type of analysis. Let's see that. So if you go to page number 23, the code says that linear dynamic analysis shall be performed to obtain the design lateral forces for all buildings other than the regular buildings lower than 15 meters in seismic zone 2. So the code says you have to go with dynamic analysis for all buildings except buildings that are located in zone 2 and which are less than 15 meters. So in simple words, if your building is located in zone 2 and if it is less than 5 floors, then only you have to go with static method. If not, you have to go with dynamic method. This is what the code says. So once we have decided the type of analysis or the type of loading that we are going to put for earthquake, next job is to run the design. So to run design, okay, we'll just start the design. Okay, again design also there are two types. One is OMRF and the other one is SMRF. There are two types of designs. and the other one is SMRF. Now what is this OMRF? It is ordinary moment resisting frame. The type of frame what we make is OMRF. Here it is known as, the other type of framing system is special moment resisting frame. Now how do I know whether this building has to be designed as OMRF or it has to be designed as a special moment resisting frame? For that again we are going to refer one more code. That is our IS 13920. Tactile detailing code IS 13920. So if you go to the first paragraph here, or the second paragraph, the code says the provision of this standard shall be adopted in all lateral load resisting systems of RC structures located in seismic zone 3, 4 and 5. This standard is optional for seismic zone 2. So that means you have to go with ductile detailing for zones that are, for buildings that are located in 3, 4 and 5. And if the building is in zone 2, you can go with ordinary detailing. The moment you provide ductile detailing, the building becomes SMRF. So SMRF in simple words means that you have provided ductile detailing. So in OMRF, there's no ductile detailing, you have just provided ordinary detailing. Now, what is this detailing? What do you understand by the term detailing? Detailing means basically how you have provided the steel, where you're going to bend the bars, for example, in beams, how this reinforcement is placed. This is known as detailing. In case if this was ductile detailing, we could have not cut the bars like this. The bars has to be run straight. So that is the difference between ordinary detailing and ductile detailing. So we'll come to that in detail later. So once you have decided what type of detailing you have done, so we'll go to ETABS and we have design option here, concrete, view revise override. So here you'll have to select what type of detailing you're going to use, ordinary or ductile. So once that is done, you're going to run the design. Now design, okay, we'll just run the design now. So we have made the model now. The design is completed. You're seeing some values there, some colors and all. So for example, for the beams, you are seeing them in black color with some values here, and the columns have come in pink color. And there is some AST value shown here. So this is what ETABS gives. So you've done with the design now. But using this model, I cannot start any construction. I mean, I cannot send this to the site and say to the site engineer, you see this model and start with the construction. So this will be of no use if I directly send it to the site. So what I have to do is I have to take the results from the model and prepare the drawings. So let's go back to AutoCAD now. So a quick revision now. So what happened? Architect gave us floor plans. In return, we prepared a GA and we decided where to put the beams, where to put the columns and all that. Once it was done, what we did was we made a 3D model and we have applied all the loads, live load, floor finish, wall load, um, self weight of the structure, then we have applied a typical live load, then the earthquake load, all the various type of loads we have applied and we have made combinations. And then we have run the analysis and then we have done the design, we have got this. Once we have got this, we have to extract the values from this and then you're supposed to prepare the sheets manually. We have an option directly to run it in ETAS, but we don't use that. This all is done manually. Manually in the sense we have some spreadsheets, we'll be using them and we'll be preparing the set of drawings. Now this is the first set of drawing what we prepare. This is known as footing layout and footing schedule. So footing layout will show where the footing is going to come, where which footing is going to be constructed, and the schedule will mention what is the steel that is going to come in that and what is the spacing of that. So footing 1, size is 2.8, length is 3.35, depth is 700, and this is the steel. So this is the first set of drawing we prepare. We take the reactions from ETABS and using a spreadsheet, we are going to prepare this. Once the footing is done, next job is to prepare your column layout and column schedule. So column layout will show where which column is going to be constructed, and the schedule will specify what is the size of that particular column, what steel you're going to put, and what will be the spacing of the stirrups. So this is schedule. So this drawing known as schedule, and this is known as your layout. Once the columns are constructed, next job is to prepare the shuttering layout. For shuttering layout, again the GA will be used. So again the shuttering layout will be prepared. In ETAS, we'll check if the column and beams have passed, and based on that, we are going to prepare the schedule, the proper one, the final one. Once that is done, once you have prepared the shuttering layout, next job is to prepare the slab details. The slabs will be designed using spreadsheets again. We are going to calculate what will be the steel coming in the slab, and we are going to do this particular drawing. And then we'll prepare the beam details. From beam details, we'll see what is the AST generated. See, this value is what you're seeing here is area of steel for the particular beam. So we'll do some calculations and we'll find out what is the diameter of bar needed there and how many number of bars are needed, and we'll prepare the beam details. Once the beam details are done, next we'll be providing with general notes. Now general notes is a set of drawing which specifies the basic details like when to remove shuttering, what will be the anchorage length, when to do curing and all that. For example, let's say de-shuttering time, it is specified here after how many days it has to be removed. All these details are given in general notes. This drawing is known as general notes. After that, we have typical details. Typical details basically says where you have to cut the bar, how do you have to bend the bar for different elements. And then we have typical details for slabs and beams. After everything is completed, we are going to prepare a report for the entire project, which is known as a DBR, Design Basis Report. Let me show you that. So this is a DBR what we have here, design basis report. So this will specify what is different things you have done for the project, what is the grade of the material you have used, which code you have followed, and all that. So this is known as a design basis report. We prepare this for a given project. So this is the details. This DBR is for another project, not for the given building. So this is what will be explained in the course for the design package what you take. So in the given package, we will be covering ETABS, STAD, AutoCAD, and detailing part. ETABS will be covered in and out, same way with STAD. We'll be covering steel structures also, different type of foundations, isolated footing, raft footings, piles, pile caps, STPs, overhead tanks. And then we are going to have site visits. We'll be helping out with your interviews. We'll be discussing interview questions. We'll be helping you to prepare your resume. All this will be covered. If you're interested in the course, please feel free to call me on this particular number 901 99 777 99. Thank you.